This polynomial equation is in what we refer to as quadratic form. It's very clearly not a quadratic equation, but you'll notice that the first term, x to the fourth power, could be written as x squared squared. So since the first term has let me back up. The middle term has x squared in it, and since the first term has that x squared raised to the second power, it's in quadratic form. And this equation will actually factor. You could factor that as binomials, just like you would normally factor, something like y squared minus 5y plus 6. That's going to factor y minus 3 and y minus 2, I believe. So we have the same setup here, just instead of y, we've got an x squared. So x squared minus 3 and x squared minus 2. Setting each of those factors equal to 0 gives us two pretty simple quadratic equations that in both cases, we can actually solve using the square root principle. So isolating the x squared, then taking a square root of both sides, we get plus or minus square root of 3 for the first equation. Same steps for the second equation. And you get x is equal to plus or minus square root of 2. So when you've got a polynomial equation that's in quadratic form, the things that we have learned about solving quadratic equations, you can use to solve that. But what you get eventually is factors that have x squared, or you get x squared equal to a number, and then you have to take the square root of both sides of that equation. You have to take square roots to actually solve for x. So don't forget that it's solving for x that you're trying to do. The next type of equation I want to take a look at are absolute value equations. If you have, we'll start with a really simple one. The absolute value of x is equal to 2. Remember that absolute value is distance from 0. So if we're solving this equation for x, we're trying to think about all the values of x that have a distance from 0 of 2 units. Well, that could be a positive 2 or a negative 2. So x is equal to positive 2 or x is equal to negative 2. If you've got a more complicated equation, like absolute value of 2x minus 1 equals 5, you kind of use the same thought process. And in that first step in our previous equation, we kind of rewrote the equation so we didn't have absolute values. So thinking about this example the same way, I'm going to start by rewriting that equation. 2x minus 1 is equal to positive 5, and 2x minus 1 is equal to negative 5. So start by rewriting the equation without absolute value symbols. That gives you two simpler equations that you can then solve for x. And one solution is x equals 3. Let's see, 2x is equal to negative 4. And the other solution is x is equal to negative 2. Now, our first step here, where we rewrote the equation without absolute value, you'll notice that we had an equation where the absolute value was isolated, was by itself. If you've got a problem where absolute value has some other stuff on that side of the equation with it, like this problem, what we've got to do is isolate the absolute value of the quantity 1 minus 2x before we rewrite the problem. So I'm going to add 20 to both sides. Divide by 4. And then rewrite 1 minus 2x is equal to positive 5, and 1 minus 2x is equal to negative 5. Solving then for x. we get -2 and +3.